Bob throws a ball straight up with an initial speed of 50 feet per second from a height of 6 feet. Find parametric equations that describe the motion of the ball as a function of time. How long is the ball in the air? When is the ball at its maximum height? Determine the maximum height of the ball, and then simulate the motion of the ball by graphing the equations found in Part A. So for Part A, what we want to do is come up with parametric equations that describe the motion of the ball as a function of time. Since the ball is thrown straight up, we're going to use y of t to describe the height of the ball, and that's going to be negative 16 t squared plus the initial velocity 50 times t plus the initial height of the ball 6. Then x of t can really be anything that we want it to be. I'm just going to have it be 3 so that we recognize that the ball is not moving horizontally whatsoever. It's simply a straight up and down movement. Now, in Part B, what we want to do is determine how long the ball is in the air. That's basically asking us to solve y of t equals 0. So we have negative 16 t squared plus 50t plus 6 equals 0. What we can do is divide through by negative 2, and that would give me 8t squared minus 25t minus 3 equals 0. I just like the coefficient on the squared term to be positive when I'm solving these problems. Now I'll use the quadratic formula to solve this equation. We get that t equals negative b, so negative of negative 25, plus or minus the square root of negative 25 squared minus 4 times 8 is a times c is negative 3 all over 2 times a. So that gives me 25 plus or minus the square root of 721 all over 16. If I work this out, I get that t is approximately negative 0.1157, which is nonsensical, or t is approximately 3.241, and this is measured in seconds. So the ball is going to strike the ground the ball is in the air rather for about 3.241 seconds. Now we want to determine when the ball is at its maximum height and determine the maximum height of the ball. What we need to do is remember that y of t equals negative 16 t squared plus 50t plus 6. So, because this is the equation of a parabola, or its graph is going to be a parabola, the time of the maximum height is going to be found by computing negative b over 2a. So that will be negative 50 over 2 times negative 16, which is 1.5625 seconds. So the ball will be at a maximum height after 1.5625 seconds. To determine the maximum height of the ball, we evaluate the function at 1.5625. So we get negative 16 times 1.5625 squared plus 50 times 1.5625 plus 6, and this gives us 45.0625 feet. So the maximum height of the ball is 45.0625 feet. Lastly, what we want to do is simulate the motion of the ball by graphing the equations in our calculator. So I turn my calculator on, and what I have is x of t equals 3, y of t equals negative 16t squared plus 50t plus 6. You'll notice that I've changed the graphing style so that it looks like a little ball on the end of a string. I need to establish my viewing window. I'm going to make Tmin 0, and I'll make Tmax a little bit bigger than we know in which the ball is in the air. Remember, the ball is in the air for 3.241 seconds, so I'll make T max 3.3. T step will be 0.01. X min can be 0. X max can be 5 because I'm graphing just x of t equals 3. X scale 1 is fine. Y min of 0, and I'll make Y max a little bit bigger than the maximum height of the ball, which is 45, so I'll make Y max 50 with a Y scale of 10. Now I graph and you watch the ball travel. There's the ball going up. Notice it starts at initial height of 6 feet. So the ball is going up, up. Obviously this is slower than real time. Slowing down as it reaches the high point, and then it's going to start coming back down. It's suspended up there for quite a while. Here we go, coming back down now. And watch how the ball accelerates as it comes down. Almost there. And the ball hits the ground and disappears. So there you have it.